Hello guys, Adam here, and today another video from the Do-It-Yourself Electronic playlist. And recently I received many questions from you asking me to provide solution for GPS tracker, for cheap GPS tracker, in areas where there's no GSM coverage because the 2G network was shut off. So I've searched for the internet. I searched the network and I found that there's a kind of replacement board that I can use for my old solution that bases on SIM 808 Chinese module, GPS GSM module, and I've purchased the board from AND Global. As you can see, this is the one. It can be purchased for something like 25 bucks currently. And it has the same pinout like a previous board with SIM 808. So this is how it is looking like. And the pinout is exactly the same. And the board can be simply put instead of all the board with SIM 808. So the same pins are available. So I thought that I would buy such board and simply port the code of the GPS tracker. So it also has a better capacitor, so at least they claim it has. And on my initial test, I found that I do not have to put the bigger capacitor here. However, I was using only LTE-M network, so you may need to check on your own with your own carrier if it's operating or not. So what about the network? So there's a page that is showing the dates, the timeline for phasing out of the 2G and 3G networks. And as you can see, in some countries like India, like South Korea, United States, Australia, it has already started, and most of networks are switching off the 2G. So it really does not apply to Europe. The dates for Europe are still 2021. But in the United States, it's hard to find a network that is currently serving 2G GSM network. So my solution that bases on SIM 808 is not applicable there. So I thought that I would help those guys to build something similar, but with the chip SIM 7000. So what about the chip itself? So if you look at the specifications, so I put also those specifications on my GitHub, so you can have a look on it. They produce the Simcom, the company that does those chips. They produce the chips that are currently usable worldwide. So they cover all of the bands for 2G and LTE category M1. So this is LTE-M. I will speak a bit later on about this technology. And NB-IoT, so this is Cat-NB. With all the bands that are used around the globe. So you can see the details here. And this technology is meant to replace 2G completely. So these modules also support SMS technology, so text messaging, and they support downlink and uplink up to 400 kilobits per second. So it is a kind of edge replacement, 2G replacement. They also draw less current, so this is what we want to have in our GPS tracker, so it could work the longest possible. And they also support putting storing data into the cloud over MQTT or HTTP. So this is a quite a good solution to build M2M devices. So I tried to port my solution, I would say, one-to-one. So if you look into my GitHub, there are a different repository named SIM 7000 GPS tracker. And here you can find the diagram, how to build the one. So this one is showed right now, it's not having quartz crystal, so it's not having clock, but I would recommend to use the clock, so to use the second diagram, because this clock is responsible for frequency of the serial port. So if it's not used, then the serial port may not synchronize properly with the module. So as you can see, the diagram is exactly the same as for my previous project that bases on BK808. But currently this board supports not only 2G but also LTE-M, so Cat M1, and NB-IoT, so Cat NB. If you want to know more about the LTE-M technology, I would suggest to go to the GSM Association page, and there's a document over here that you can read, and it will give you some clue how this technology exactly works, what is available, because the LTE-M is not only a replacement of 2G, it also provides some other features, especially for M2M devices to provide a longer lifetime for those devices. So there are special features for those devices like power saving mode, like extended DRX. I would suggest to go through this document. You may want to look what is available. Of course, these features are already available in the module, but you need to consult your carrier if you are able to use it, and how to configure all those features. So then I would be able to use, for example, power saving mode timers, extended timers. Okay, so I will show you in a minute this device, how it is looking right now. I mean the prototype, and I will also maybe right now I will show the code, what is different. So on the left side we have old code that is working with the SIM808 module. So the main difference is that the new module, it requires to send only carriage return side. So this is a /R. It doesn't work when these two characters are sent. It has to be only one. As you can see in the code, this is only one. The same applies to all of those commands. So it's not 100-1-to-1 interchangeable. You need to modify a code slightly. So /N/R has to be replaced with /R only. Also, there are some commands that are missing. For example, on SIM808, I was able to use a voice calls. On SIM7000, it is no longer available. Also, for the GPS commands, there was a GNSS and the GPS sections separated in old module. Right now, there are bound into single sections, so the commands are only used for the GNSS. For example, so I had a commands to enable GPS like this one, GPS status, GPS information, GPS reset, GPS power. Right now there's only GNS. So whenever it was with GPS, now it's GNS. CGNS power, CGNS info, CGNS cold start, CGNS hot restart, CGNS power, and so on and so on. So those are the difference. Basically, the code changed only a bit, and I had to remove the part that was responsible for answering voice calls, so you won't be able to query the GPS status by voice call. Only the text messaging is available, but still the commands for the text messaging remain. So it is, I would say, ported in 90%. So you will see that in several minutes when I'll be showing how it works exactly. Okay, so maybe now I will show you how it's looking like. I need to switch off my PC and move to the video camera.
Okay guys, so remember this previous version of GPS tracker that was based on the SIM 808 module, so you can see a pinout here. And the module, as I said on my previous video regarding GPS tracker, was not so well constructed. So the issue was with the capacitor, so that was for SIM 808. However, for the newest module, that is LTE-M CAT M1 and CAT NB capable, this is not an issue. So the capacitor is much higher and it works perfectly well. As you can see, pinout is exactly the same. We also have a USB port here. However, I will not be using this. And we have two connectors, one for LTE antenna and second one for the GPS. On the old module, this 2G, there was also GSM and Bluetooth, which I haven't used, and the GPS. The modules are exactly same size, so these are exactly same size and they fit into the same board. So as you can see on my prototype, I have a GPS antenna here, GSM, also LTE-M antenna here, and here it is connected to the module. No additional parts added and it should work straight away. And this board remains the same as in my previous solution. This is actually the same board as I showed previously. However, it has fitted quartz crystal and capacitors to provide a stable 8 MHz clock, and it has this connector here that I also added to allow me to interconnect with the USB to serial port adapter, so I could show you how it works in a minute. And this is a connector to the SIM 7000G module, which is basically the same as for the SIM 808, and is all powered from the USB power bank. However, keep in mind that this USB power bank needs to be quite simple, because some more complicated power banks tend to switch off the power when they discover that the current is quite low, because that means that they actually charge the battery of the mobile. So this is all, and this is how it looks like. It's quite small. Fits into, I would say, less than 10 centimeters box, and it works pretty well. The best thing is that this LTE-M module, it draws less power than the previous one, I mean the SIM 808. So just one more look on the modules. So on left side SIM 808, on the right side SIM 7000E. In this case, this is how they look like, and in a minute I will show you how the software, how my code is working with this SIM 7000G module.
Okay, I forgot to mention one thing. So after you buy the modem, you need to pre-configure it first so it could work with my code. So the configuration means that you need to change the speed of the serial port. And to do it, you would need to have a USB to serial port adapter that works on 3.3 TTL logic. And for example, it might be one with the FTDI 232 chip. And if you buy it and connect to your Windows or Linux, whatever you have, you need to check what is the virtual port that is used to interoperate with this module. And in my case, it is serial port COM number 4. So I have a PATI terminal here, and I have configured it to work. So first, when you connect the SIM 7000G or A or E, whatever you have, you need to connect over serial port speed 115 kilobits per second. So I will do it right now. Okay, I have terminal launched. Let's resize it a bit. And now I'm connecting the 5 volts to the SIM 7000G module. Let's see if it's sending anything. Okay, it's now powered on. Okay, so it's sending something. So let's see if it works. I will send command AT. Is okay. And to reconfigure the module, you need to issue the command maybe with the capital letters. And let's check what is the command. So I mentioned about this command on the beginning of the code. So it is AT plus IPR and 9600. That's the speed of the serial port that would be used to communicate in my code. So let's make it AT plus IPR. Okay, now it is done. So now the device will stop responding on the frequency 115 kilobits per second, and you have to close your PATI, you have to run it again, but with other speed. Now I have a second setting with serial port 9600, so actually other settings, so we have a parity off and all these details defaults. And now let's open it. Now it should respond AT, okay. And now we should write down the speed to the flash memory. So let's see what was the command in my code. It was, I believe it was AT and W. So let's see. AT and W means right. So it's something like this, AT and W. Oh, that was wrong. Let me check. It must be somewhere else. Save config, AT and W. I don't know what it is, not maybe because I use delete key. So AT and W. Okay, now it is saved, and now you can use the modem with my software. I mean the SIM 7000G module with my software, because otherwise it would not cooperate, because my software and the Atmega chip that is used in this project will operate only on 9600 speed on the serial port. Okay, now let's see how the code works exactly. So in the main function, you have a main portion of the code. So basically, it should wait 10 seconds at the beginning. So let's switch on the unit. On the right side, you have an output of the SIM 7000 module. So I'm switching on. I just applied 5 volts, and the code waits 10 seconds. So after this, it should turn the echo off. So it was done. Then it sets the speed and writes down the configuration into the flash of the SIM. Then it tries to check the pin if it's valid, deletes SMSs that are in the memory, and waits for the registration of the 2G or LTE M network. So it is waiting something like 1 minute. And then there's a never-ending loop that waits for the incoming text messages, and we'll get that point into us 30 seconds. So let's wait until the registration. So the registration is the AT plus CREG command, so it should output CREG 0, 1. That means that the module has registered to the GSM or the LTE-M network, so it is going to happen, I believe, in 1 minute. And then we'll see how the module is able to respond on text messages sent from your mobile. So we need still to wait because there's something like 60 seconds in the check registration procedure to give some time to the module so it could register into the network. So this is the point here. It waits 60 seconds, I believe, until the module registers into the network. Okay, so we got the CREG 01. That means that the module has already registered. And then we get to this never-ending loop in which the software waits for the incoming text messages. So now, yeah, by the way, it also switches the module into the sleep mode, so it would draw the lowest possible current, and switches off the GPS function. It will be switched on only when needed. So now it waits for the incoming text messages. It checks the signs on the serial port. So let's send a message like a single. That means the perform a single measurement. I'm sending command single. On the right side, you will see that there was incoming text messages. Now it switches on the GPS and it sends back information to my mobile that the single measurement is now in progress and please wait several minutes until it is completed. So right now it should enable GPS and output some data and try to fix on satellite, but of course that is not possible when I'm in my home because indoors the GPS are not visible. Okay, so in the output of CGNS information, you will see, when you of course outdoors, you will see somewhere here on this 4 and 5 position information about the altitude, longitude, latitude, all the details that are received from the GPS. Of course, that will be not possible here because I'm indoor. But if it's received, if the second field here is not 0 but 1, it means that the module has fixed on satellite and is able to receive a position. And if it's received, then it will send back this position with the text message to your mobile. So that is basically the concept of working of this unit. There are also other commands like multi, means perform several measurements, and guard. Okay, I will not be doing an outdoor test today because I don't want you to know exact location of my house. However, you can do it on your own. I hope you enjoyed the video, and if you have any question, just drop me some comments and don't forget to give a like and press the subscribe button. Thank you very much for your support, and bye bye.